Dear students, welcome to my YouTube channel PCM Academy. Let us continue our discussion on commutation relation and we will discuss some more result in this class also. So you should remember this result and you can understand how you should write the result, how you can remember. That I have discussed a lot of commutation relation in the last class, and now I will give you some more result on commutation relation. Then we will conclude the mathematical tools of quantum mechanics and we will start the postulates of quantum mechanics. So if you talk about the mathematical tools, then this is the last class. Okay, so let us tell you about some more commutation relation. Commutation relation. So now we will discuss commutation relation between the angular momentum that I have told you earlier, but as convention, let me tell you again. So in the last class we have discussed about the between the angular momentum and the linear momentum, angular momentum and the position, commutation relation between angular momentum and position, commutation relation between angular momentum, linear momentum, and this is commutation relation. Now we will discuss the commutation relation between angular momentum with angular momentum. So you know, if you have Lx, Ly and Lz, but the commutation relation between Lx and Lx, between it, if a commutation relation with itself will be 0 always. So Lx x cap with Lx cap will be same as Ly cap with Ly cap will be same as Lz cap with Lz cap, and that will be 0. That will be 0. But what will be x with y? Suppose if you have Lx with Ly, if you have Ly with Lz, or if you have Lz with Lx, so we should have this kinds of thing. Now how you can write this? So first again you have to see this x, y and z, and x to y will give you z, y to z will give you x, and z to x will give you y, and this direction, this is the positive direction, so the reverse direction will be negative. So you can say x to y will give you z, and that will be I h cross Lz. Similarly, y to z will give you x, that means I h cross Lx. Similarly, z to x give you y, that is I h cross Ly. Similarly, you can write for the reverse case also, if Ly Lx, that will be minus, Lz Ly, that will be minus I h cross Lx, or Lx Lz, that will also be minus I h cross Ly. So this is how you can write that also. Okay, now let me tell you one more thing about the angular momentum operator, that is L square operator. Okay, suppose if you have L square, so you know L square is nothing but Lx square plus Ly square plus Lz square. Now if you talk about the operator form, then it will be L square cap, Lx square cap, Ly square cap, and Lz square cap. Okay, so this is the total angular momentum L, and this is the component Lx, Ly and Lz. But if you want to know about the commutation relation between L square and x, suppose L square with x, Lx. Okay, so what you will get, L square means that will be Lx square plus Ly square cap plus Lz square cap with Lx. So what you will get, you will get Lx square with Lx, Ly square with Lx, and Lz square with Lx, and this all will be 0. This all will be 0. Okay, so if you write it in this form, Lx square Lx plus Ly square Lx plus Lz square plus Lx, all are 0. So this will be 0. So your square L square operator with any of this, maybe it is Lx square, maybe it is Ly square or Lz square, it will give you always 0 result. So that will be same as, you can write L square operator Ly cap and L square operator with Lz cap. So these are same. These are give you same result. Okay. Now I have discussed in the last class that we will discuss another important operator, that is called actually ladder operator. So this is just a special type of combination of Lx and Ly. So you should know this also. That is ladder operator. Okay. What is this? Ladder operator has two kinds of operator. One is L cap plus, that is the combination of Lx and Ly, that is Lx cap plus I into Ly cap. Okay. Similarly, this is one kind of ladder operator, and L cap minus is nothing but Lx cap minus I into Ly cap. This is your second result. Now, if you want to know the commutation relation between the ladder operator and the LZ cap operator, because x and y are here, Lx, Ly are here. So sometimes you need to know about the commutation relation between Lz and L plus. So in that case, what you have? You have Lz cap plus, comma, Lx cap plus I into Ly cap. Now if you use the linearity property, then you will get this Lz with Lx first plus I into Lz with Ly. Now you know Z with X again. If you take X, Y and Z, so Z with X will give you Y. That means I H cross Ly plus I into Z with Y. That means it is anti-clockwise, give you X, but it will be minus I H cross Lx. So it will be just, you can see, H cross Ly, I square minus 1 minus plus, and I is 1 here. So it will be a plus H cross Lx cap. Okay, H cross Lx cap. So that will be, if you take common H cross, then it will be just Lx cap plus I into Ly cap. And you can see this is again L plus. So that will be H cross L plus. So if you take Lz with L plus, that will give you H cross L plus. Similarly, if you take, you can check if you want, that if you have Lz with L cap minus, then you will get just minus H cross Lz plus. Lz plus. L plus, sorry. L plus. Sorry, this will be L minus. For minus, it will be L minus. Okay. So this is how you can remember this result. Okay, and you can see the result with Lx instead of Lz. You can see with Lx and Ly also. So that will give you sometime Lz. So you can check this result. Okay. So this kinds of result you have to remember. Otherwise, you little bit of results you have to be understand for how to prove also, because something like this kinds of result, if you want to prove, then you can prove it. So your time will be your pressure